Good afternoon. So, for the biomedical signal processing that course we have taken, the first course we would like to take, it is from Susmita Bhosle, that the question is what will be the motive of this interactive session. That the reason or the motivation behind this interactive session is to increase the interaction and to understand the participants and their needs in a better way. When I take these lectures as a tutor of this course, I find very handicapped, because when I take this class in regular teaching mode, then I can see the faces of my participants and it automatically gives me a feedback that how much they are appreciating it. If they have difficulty in understanding, I need to spend more time, I need to explain it more. If they are getting bored because pace is low, then I can speed it up. So, I continuously keep on getting that feedback, and that has become as an habit that I take it for granted. But when I am taking this online course, I could actually realize that that is not all the time which we can take for granted. We do not get the feedback that how the participants are feeling about that course. So, I think it gives me an opportunity to interact with you and to reply to your queries. So, that is the motive behind this interactive session. Next, I would like to go for the second question by Sri Lakshmi Dasari, and many more people in the forum asked for this question, that what about the notes of the lecture and PDF. Now, preparing the transcript is in the agenda of that NPTEL team, and IIT Madras it is looking for it. They are in the process of preparing it. Once that is available, that would be shared with you. But till that time it is prepared, I think that we have enough material to go through, that the class lecture or the video lecture what we take, that is just providing you a cursor to what to read and what is the sequence to maintain. And in the beginning of the course, I have provided actually a number of references. When I went for that second phase, also I have provided actually the references and added one more name. I would like to go through them once more. So, if you look at these courses, that out of them that 3 books we have highlighted here, all of them they are on biomedical signal processing. That all 3 of them can actually be a text for this lecture course. So, I think if you can get it from the library, it would be the best. If you cannot get it, then I think you can buy it from the shop. We have the Indian edition and the international edition, they are pretty affordable. So, if you do not get them in the library, then I would suggest that you should try to get them one copy of one of these books, which can actually provide you that the notes or what you are looking for. The PowerPoint presentation or the transcript, it can at best give you some bullet points, it cannot give you the whole story. So, if you want to get the mastery over the subject, you have to go through some book, and you can choose any one of these books. And the 3 books I have highlighted here, one by William J. Tompkin, the other one is by D. C. Reddy, and third one is by R. M. Rangayan. All 3 of them can serve the purpose of text, and the other books they are I would say they are the references. Okay. So, time to time they may be required, but if you have one of these 3 books, R. M. Rangayan, D. C. Reddy or that Professor Tomkin, then I think your purpose would be served. Next, I think many more people has asked in the forum as well as in that Google sheet that what would be the type of questions in the final exam. It would be exactly similar to the questions you are getting in the assignment. In the assignment you are given number of questions and all of them they are multiple selection or multiple choice. So, you will get just similar kind of questions. So, either from your knowledge you need to select one or multiple of them, or sometimes you need to do some small computation using calculator to get the right number before you make the selection. So, that would be about the final exam. I am not taking the name of the participant who has asked these questions, because I think there are a huge number of participants ask the same question. Next question, that from Prince Saini. The fourth question is that is it possible to process EEG signal in real time? Yes, it is possible. That there are number of techniques actually to do it. First of all, from week 9th when we are doing the tutorials, in many places actually that I pointed out there that please look that filters what is used, they are integer filters. So, you know that if you try to do some addition or multiplication that in your computer, that if it is integer it takes less time. If you want to have that a silicon implementation of the same algorithm, it takes less space and less actually that the computation. So, if you can do the processing with integer number, that would be the best. The first step towards it is first you implement it in MATLAB or Python. So, check the functionality of it and you get an idea about that how much time it takes. Next, you can choose an appropriate platform. It could be an embedded processor like ARM, or it could be that actually that FPGA for which you need to do that VHDL programming, or it could be a DSP like TMS 320 from Texas Instruments for real time processing. So, depending on that how much computation you need, or to be more precise that when you are talking about real time, that means you have a constraint over the time over processing, that maybe you can just wait for the next sample to arrive. So, within that you need to compute that whole process and be ready to take the next sample. So, for that you have to choose appropriately that what platform you would take. And if I want to actually name one of the real time application, that nowadays the pacemakers are there, they are actually supposed to give a beat, because the heartbeat, the signal comes from the SA node, it may not be coming all the time. So, pacemaker is supposed to provide that beat. Now, initial the prototypes or the initial days, the first generation, the pacemakers used to all the time provide that beat. So, whether SA node is working or not, it is continuously working. Now, the effect of it is that it would need actually a bulky that battery, and still the battery will get drained because it is working all the time. So, after that the researchers they found that SA node is not that bad. Yes, some problem is there for a particular patient. So, they are not working all the time, but most of the time they work. Sometime for some problem they do not actually give the beat in time and the patient suffers for that. So, they made the pacemaker so intelligent that it would be waiting for the SA node to act, and if they find that SA node has missed the beat, then it will take over, and still it will again keep and watch whether the SA node has actually taken up its job again. If the SA node again started giving the beat, then there is a chance that you can have actually that ectopic beat, because two signals or two commands are coming. So, the pacemaker again will take itself in sleep mode or listening mode and allow the SA node to work in the normal way. So, that is completely in real time it does the job. So, there are lot of applications for which the biomedical signal processing you will find that it works in real time, and I would say that it is not a that big a challenge, because if you look at the signals, the frequency of the signal is much less compared to the communication signals. So, it is highly possible to actually that process them in real time, and it is done in real applications. Next question, I get that we have clubbed actually number of questions, one from Vijayalakshmi Bandi. That question is, I want to do PhD on signal processing, please give some suggestion and some idea to start my research. That next that along with that, in similar line, what are the open problems available if we want to continue working on biomedical signal processing? This question has come from Hari Sarup, and that I would say that such questions should be taken one-on-one basis. That means, you should ask the question on personal level to any faculty. You can go through the web page of IITs or NITs and find out that whose interests are actually matching with yours. There are number of actually good researchers in India who are working in biomedical signal processing. At present, I look more towards that image processing, medical image processing rather than the signal processing. Anyway, you can contact in any one of them, and it would be the best to get the suggestion from them. And there are number of open problems, and they are working on them, and all of them could be very good use for the mankind, and that it can help to the people of our country as well as throughout the world. And one more point, that all such applications, they are for the peaceful purpose, which we sometimes we miss for the other technology. Okay. So, you are most welcome to do the research, but I think such questions should be asked in person to one expert with whom you would like to work. So, okay, we have some more questions already given in the Google Sheet from JRS. I am doing one project in my college, what is based on biomedical application. I want to analyze and measure FAB P3 protein level. Can I do this with the help of this course? I am very sorry, I do not know enough about that FAB P3 protein. Now, if you share some information that how it works or so, then we can try. So, this course is primarily for that biomedical signals and how that signal can reveal the internal physiological process going in the body, and thereby you can get that whether those physiological process they are going in a normal way as they are expected to go, or they are facing some problem. Okay. So, sorry, I could not help you at this moment. Next question is the basics of nonlinear analysis of EMG signal. This question has come from Purnima PN. In this course, primarily we are looking for that linear actually processes, linear signal processing I would say, and we have not gone for the nonlinear models. However, if you have any nonlinear model in mind, yes, they can be tried. People have used them for different kind of biomedical signal, because linear signals always cannot actually express the complexity of that signal. The other way you can look at it, that all these signals they are basically non-stationary in nature. So, another alternative to the nonlinear system is that linear time invariant systems. That is also another alternative you may explore. However, in this course we cannot go up to that. So, we restrict ourselves from within the boundary of linear signal processing. Now, let us, we got just one more recent question by Shivangshu Tyagi. The question is, what makes biomedical signal analysis more difficult or challenging than other physical signal analysis? So, it is a very good question, that if you look at that the signal processing, that the two sources you can get, one is the real signal, it could be human speech, it could be some biomedical signal like ECG, EEG or some other signal. Other broad actually category of signals are communication signals. Now, in communication signals I would say the signals are much more well behaved, because you know the source of that signal, that is man made. However, it becomes complicated when it is passed through the channel, because the deformities that comes in the channel or the channel transfer function, you need to really find it out. We model it as a linear way. However, it could be non-linear at times, and there are many challenging applications. Like one simple application you can look at is the ADSL modem, that is we call the broadband access technology. Those who still have that the wired telephones, we know that we can get a high data rate within that, and the principle of it is very interesting, that only up to 8 kilohertz, that is the bandwidth that we are using for the voice actually speech. Within that we have the signal. Beyond that there is a huge bandwidth for that cable, but that bandwidth is not utilized primarily for the reason that that part is very unreliable, in the sense that from one actually cable to the other, that in between, that means the from your actually instrument to the exchange, in between the pathway that the channels are there, that is the cable connections, they are not same, and because of that their attenuation characteristics in different frequencies are different. So, you cannot standardize them. In case of ADSL modem, what they do, they break that into multiple actually channels and check all of them, and find out that which are reliable or strong in terms of the SNR, and they pump the data within that, and they dynamically actually look at that, because these characteristics also changes with time. But still you know that there is a pattern that how the modulation would be done, those things are known. But in case of the biomedical signal processing, the main challenge is that the source is actually that the human physiology or the human body, and each one of us is little different from the other. So, signals are changing, though the overall pattern may look to be similar. So, treating them becomes more difficult, and the variation is more in that case. And what I would say, that there is continuous variation. You will get a spectrum of people whom we can tell that they are actually normal. If you go to the doctor, they will tell, yes, you may find it actually different from other people, but it is within the normal range. And same way, that those who are, we call that having abnormality or pathogenic signature, there also a lot of variations are there. So, that makes actually biomedical signal processing more challenging, but the good part of it, that biomedical signal, the frequencies are much low. So, that makes the thing easier in terms of the real time implementation. However, for the analysis of the signal, it is not actually that easy, and it is actually more difficult than the that communication signals. So, these are the questions we have at this moment. If you have any other questions, you can just actually text it in the chat box, and we would be ready to pick up those questions. Okay. So, regarding the exam, we can actually take some of the that points, that first of all in the exam, that what I get, that there would not be, that MATLAB will not be available. So, that there are few questions based on MATLAB and primarily they are introduced so that you can appreciate the text in a better way. Those questions those questions actually we would not be able to ask you in the exam, simply because that the MATLAB support will not be there at the time of the exam. Okay, you will not have access to the MATLAB. So, those kind of questions will not be there. However, keeping that in mind, if there is any small computation, we would keep them small, so that you can do those computation using calculator if you know the equations. Okay. We got one more questions. So, let us take that before we come back again to the exam. How to understand mathematical equation for biomedical signals? This question came from Pankaj Keshari. It is a very good question, Pankaj, that when we actually teach biomedical signal processing, we try to go step by step to explain you that what are the assumptions taken for that, and that the way you have to do that, you need to take actually those equations and try to derive it yourself, and whenever you will fail, then if you cannot do that, you should look back to the book or the notes to see that how the derivation is performed. There are number of tricks that is applied. Sometimes there are different formulas that is used, usually we provide them, and sometimes it is from our the knowledge of signal processing. So, here what we assume actually that you have the knowledge of signals and systems, that is a must, that you should have that to take this course, and if you have that background, I think that it is not difficult to go through them. The only thing you need to patiently go through them line by line, and you should try to derive them that line by line, and there is no point trying to memorize them or mug up that is not required. You should appreciate that what are the tricks played at different steps to get the desired answer. So, how the manipulations are done at every step, and the best way to do that you do those calculations line by line yourself. If you find it difficult, look at the book or the note, see that how they have done it, try to get that what is the formula they have used that to actually make that change or manipulation, and then how it proceeds. So, that is the way to actually understand the mathematical equation for biomedical signals, and if you have some specific question regarding some derivation, that is how you have gone from line 1 to line 2. So, in that way you can make such pointed queries in the forum. We would certainly try to reply to you. So, going back to the exam, that we need to look at that the whole syllabus, that is one of the criteria to be prepared for this exam. In the first 8 weeks, we have actually covered the whole syllabus, and after that we are taking the tutorial, so that you can appreciate those actually theory in a better way, and that also helps you to get acquainted to the real signals. Otherwise, after taking that course, if you do not know how the carotid pulse signal looks like or how the ECG signal looks like, then I think that we have not been really successful in teaching you. So, you would get the introduction about that, you would know that what are the specifics of that different kind of signals, and at the same time you have a brush up of that the syllabus which we have taken in the first 8 weeks. So, you have gone through that, you have covered through the whole syllabus, and I think you have also participated in answering the assignments of that. So, that itself is a good practice actually for the exam. So, in the exam you would get very similar kind of questions, maybe a little deeper, because over the time you are expected to have more insight into that subject. So, few questions would be there which would be just like that assignment, very easy. Some of them, if you just read through that course or just listen to the course, even you are unable to do the assignments, you should be able to answer. For few questions to answer, you need to have that practice of actually writing those assignments, and for few of them you need to learn a little more, you need to go through the books and to get a little more understanding. So, primarily that the questions could be divided in these 3 categories in terms of difficulty, though all of them there would be short questions, there would be each one of them would be of 2 marks of and you will get 50 such questions. So, that you get 100 marks to answer within that time. So, we will have plenty of time because they are objective type actually questions, and I do not think that you will have any difficulty in actually finishing that the question in time. We got one more question from Ashish Kumar Das, how the morphological characteristics are used to use as a feature and classification of ECG signal. That in case of ECG signal, that we look at that the different kind of characteristics. For example, that the first thing what we look at, that what is the rate at which we are getting the ECG signal. For that we look at that when the beats are arriving and the interval between 2 beats which we call as RR interval, we actually take that is the first signature for the ECG. Then we look at that other characteristics, you know that the people have tried correlation, that is one. Then due to ectopic beat, that the QRS complex may be jaggered because of say that deprivation of the blood or supply of oxygen due to that lack of blood supply, which we call as that infarction and then ischemia. That in such conditions we know the ST segments get elevated or depressed. So, all these changes we have quantified in a little different way, rather than trying to take that as a shape, we have derived it as a lumped parameter when we have taken the signal length. So, in different way actually we have actually taken those morphological changes or captured those morphological changes in terms of feature to get that whether this actually signal is coming from a normal subject or it is coming from a person who is a patient. Okay. So, that is the way we can do it. This is just an example, but if you have some particular difficulty in mind, that we can actually look at that. The next question is from Lalit Arjun Kher. Why are not medical devices developed and made in India despite good R&D in IITs? Lalit, thanks for your compliment that IITs are doing good research. I think it is not the just responsibility is not restricted to the IITs. IIT is actually some institute, they are named as IITs. Throughout the India, there are so many institutes and researchers are actually distributed across the academia and industry. All of them they are working for that new actually the work, they are doing R&D and finding out the new technology. So, I think we need their help to actually get the devices developed, and that the devices are taking place. It is not that it is not taking place, just this week only I got some mail that a device is developed which can be plugged in with the mobile phone, and with the help of that you can actually check the blood sugar. So, instead of a separate blood sugar measurement device that is plugged in, it becomes a plug in with the mobile phone, that is developed in India. I just got that promotional email in this week. Now, the question is that why it is less in India. The first point I would like to tell you that for the medical device, there are some regulatory bodies you need to first take actually their approval. Unlike other technologies, say you make a new mobile phone or you have a new technology that which is used for some purpose, unless there is a safety concern, you can directly take it for use. On the other hand, because you are talking about the human subjects, so safety is for utmost importance. So, first you need to take it through the clinical trial, and then only you can actually think of using it, and then you need to get the approval of the regulatory authority, that Food and Drug Administration, then you can go for the market. That is one extra actually hurdle than other innovations. Other innovations you need not have to take care of this part. And then when you are talking about the human body, if you are trying to do something invasive, then you need to look for the biocompatibility. Even for non-invasive one, that if you want to strap some say electrode on the body, you need to look at the long term effect of it. If you put it for number of hours, whether that will be good for the patient or it may create some other undesired effect, we need to take care of that. That makes actually the process of innovation or that research to the translation of the research to the market more slow, the time required is more, but the things are changing slowly, the youngsters are coming up, and that Government of India is giving lot of incentive for the young researchers, that so that they can actually become entrepreneur and do something new. So, I think that we will have soon actually more such technologies from India, and they have to compete with the multinationals who are already there in the market. That is one more hurdle, and we are actually looking forward that how we can actually take care of that and become a hub of R&D like Israel. Next question we got from Lalit Arjun Kher, that the question is, what is the current status of indigenous research and manufacturing of high-end biomedical equipment, as for example MRI and CT scan? Now, I think multiple things have come together. Now, that if you look at that high-end biomedical research, I think the best place is to look at that. You please look at the imprint, that initiative that has been taken for that the biomedical signals and systems actually initiative, that a lot of projects has been taken up in IIT Kharagpur first and then throughout the India, that you can get, if you look at the imprint page, you will get that idea that what are the works are going on. Now, next part of the question is about the biomedical equipments like MRI and CT scans, that such equipments are already there in the market. It is developed by different companies and they are already in use. So, I think that the R&D should not be to make that these old machines. What should be done, that any business group wanted to get into that, they should make use of the technology available and prepare actually those machines and sell in the market. And there are companies who are actually getting into that sphere, CT, MR or the big medical equipments. We know the three big companies in this market. G is the market leader worldwide as well as in US. Next is Siemens. The close third is Philips. That both Siemens and Philips, they are based in that their headquarters in Europe. That G Healthcare is from United States of America, and their main business is first of all North America, then Europe and then the whole of that the world. All the continents they are doing business, they are the big players. Followed by them there are different Japanese companies, that Fuji and all, they are making actually equipments for some modalities, not for all. Okay. And there are actually disruptions, new players are coming. For example, that Samsung now their R&D, they are working on that MRI and the CT scan machines. So, they are trying to take that position as one of the big player in the world market. So, that and they are working from their country, that is their base country is their South Korea, as well as they have a big lab in India, in Bangalore and Gurgaon, in other places. So, they are also working from India and they are working for these equipments like MRI and CT scan. And if any other actually business group they want to come, I think that first they need to absorb the technology what is there in the market, because for such a big machine all the things it is not actually easy to absorb all of them. Some of them need to be outsourced, maybe sensors need to be bought from other company to develop that equipment, and R&D would be required to create a differentiator, that when you try to compete in the market, you will see that the products are coming with new features. For example, when you look for your new mobile, you look at the spec, that what is the size of the screen, what is the screen resolution, how good is the camera. So, every day the new features are coming in the new model. So, when you change that model, you need to have your R&D or you need to take it from that the other R&Ds, you need to take that, so that you can make add new features. So, R&D is primarily required for that, for new generation of the product, but as such the base technologies of MRI, CT, all of them they are standardized, and for that you do not need to do the R&D for actually at least high end R&D for that. Okay. Though that how to make the prototype and all that itself also would be a pretty good challenge. Next question is from Rohit Apurva. Why P and T waves are low frequency signal? Okay, let us look at that the ECG signal. So, what we can do that if we look at the ECG signal, that this is P, then followed by QRS, then T signal. This is a lead 2 signal we have taken. Okay. So, that here we have drawn that. Now, if we look at that, what are the events going on? That P, that is signifying that start of the contraction of the upper chamber or the atrium, and atriums, if you look at that, they have very thin wall and have very low amount of muscle. Why that is so? If you look at the heart, that 4 chambers, that their job is just to accumulate, the upper chambers, their job is to accumulate the that blood which are coming from the vein, and just it should have the pumping capacity good enough to pass it to the chamber just below it, that is the ventricle. So, that does not need that big muscles. So, the activity of it is lower in magnitude, that is one part, as well as because they are slow, that low intensity actually activity, there is no special nerve fibers to distribute that signal. So, that they simultaneously get compressed all the muscles of the upper chamber. So, the flow of the signal is also slow through the muscle fibers. On the other hand, when it comes to the QRS complex, that after the AV node there is a network of actually that the nerve fibers, that we have the bundle and then bundle branch and then the Purkinje fiber, which distributes the signal in all parts of the ventricles, and from there that the ventricles would actually compress simultaneously, all parts of them, all on a sudden they start the compression. So, it becomes actually a much faster action. So, that is why QRS complex is actually much faster, and the T wave, if we look at, that is when the relaxation of the ventricle that is happening, and for that if you look at that, there is no actuator. After your depolarization of the muscles, the repolarization will happen. That is a autonomous process. So, that thing happens individually in each of these muscles. So, that part is happening slowly. So, out of these activities, the QRS complex, it is given by a command, and the command has reached all the muscle cells of that simultaneously. That is why we get a much faster actually response or much faster activity in case of QRS complex compared to P and T. So, that is the reason we can say. The question from Ashish Kumar Das, what are the parameters may be used as feature for beat classification problem based on morphological characteristics of ECG signals? If you look at the beat classification, that the primary problems what we get, that is whether it is that running fast, that is tachycardia, or if it is slow, that is bradycardia, or if it is having a fluctuation, that we call that is the third category of the problem. For that, if you take the RR interval, I think that is good enough. But if you want to know that why this is happening, that why there is change in the beat, then I think more measurements would be required. Instead of or rather along with the RR interval, you may have to take that PP interval, TT interval, that from the P to Q, then that the width of the QRS, that is Q to Q to S, then S to T, all such measurements can help. It depends on that abnormality you are looking at. I missed the name of this question who has asked this question. Which company is manufacturing best EEG acquisition device? Again from Ashish Kumar Das, there are number of companies, and I think we should not try to name any one of them, because here we are not to actually praise any company. So, I think the best thing would be you look at the web and look at the customer satisfaction and that their customer feedback for this. The question from Rohit Apurvo, how wave shapes and waveform complexity in biomedical signal relate to characteristics of underlying physiological phenomena. So, for that, first we have to look at that select one signal. For example, if you look at our EMG signal, in case of the EMG signal, we know that whenever we try to actually actuate the muscle, then we get the EMG signal. So, how big is the effort that we can get a measure of it, that how many times the same muscle fibers are actually employed for the job. Okay. They are to give actually more force, they are actually actuated, or they are excited again and again to contract to give that force. Now, for that what will happen? First of all, that because they are employed number of times, you will see that the frequency of the waveform will actually increase, and because more and more muscle fibers they are getting actually actuated, that the waveform what we will get, the intensity also will increase. That we can actually get through the measures like local RMS, or we can look at the envelope of the signal. So, these are the tools we can use to actually measure the wave shape and that complexity of the signal, or that how the process is changing within itself, that how much effort is actually given by the subject. So, we need to first select a particular signal, and then you need to think that what are the change of shape happens because of different actions. Now, what I told you in EMG signal, these things are all can happen for a normal subject. For that, one person need not be a patient. Now, in case of a patient, however, the characteristics of those change will be different, or the magnitude of those envelope or the turns count will change for the same effort. So, from that we can also actually distinguish whether this person is normal or suffering from some disease. So, now let us go back to the one more question has come. So, question from Rohit: how to analyze variability in signals such as EMG? Just now we have taken up that example of EMG, and we are explaining that how that when we try to exert force using our muscle, that the activities will go up more and more times, that same muscle fibers should be excited, and because of that we will see that the turns count will change, as well as as more and more muscle fibers are employed, then our actually the intensity of the signal also will change. Okay. So, we just explained that. So, I am just repeating that same thing. How can we determine fatigue of the eye by analyzing the EOG signal? Okay. So, first of all, to do this we need to look at the EOG signal. I have not worked with the EOG signal, but I can tell you the way that how to proceed, the general way that how to proceed with that. We should first look at the EOG signal, look at the nature of it, and that first we should take from the normal subjects and see that how the signal pattern we get for normal subject in normal condition. Now, when the fatigue happens, we need to see that changes. As human being, we have much better capability to look at the signal and find it out that what is the change, and I think to know more that what are the changes are happening in the signal, we should take the help of an expert, and the clinicians or the doctors, they are the best people to help us who are working in this area. They would be able to point it out that these are the changes in the signal, and once we know that these are the changes visually we can appreciate, then we need to design the algorithm that how we can actually capture them, and already we have learnt a number of tools. So, first we should try with those tools. If they are sufficient, then our purpose is served, that we can measure actually the fatigue in the eye. If not, then we have to think of the new tools which can actually measure it in a more reliable way. Okay. So, that is the way we can proceed. However, I myself have not worked with this signal. So, I cannot give you actually immediately any solution for this. Okay. I think we got again the same signal or same question from Ashish Kumar Das. Ashish, my suggestion would be the same, that you should collect the signal and look at the signal, try to figure out that what are the changes, but as we are not expert, it would be difficult to actually differentiate the differences, because many times the differences are very minute differences we get in the signal. So, you should take the help of clinicians to appreciate those changes, learn those changes, and once we learn those changes, then we should think of that what tool would be the best to capture that change or magnify that change, so that we can actually measure that. At the same time, that those actual tools should be robust to the noise, it should be robust to the variation in the signal, because the signal coming from no two subject would be same. Even for the same subject, over the time you will see the signals will change. Okay. So, the tool should be actually robust to all such undesired changes, and then only we can say that we have found a good solution to it. And our time is over. So, I enjoyed interacting with you, could get that how you are actually preparing for this course and how much interest you are taking for that. I hope you have also enjoyed, and thank you for actually participating in this interactive session. Thank you.